book we just got through talking about was The Philosopher's Stone. We talked about alchemy, and we talked about the fundamental goal of alchemy to find some universal premise, substrate, underlying matter. And that leads us right to your book, Secrets of the Unified Field, the Philadelphia Experiment, the not-so-known discarded theory, because this is about Einstein's unified field theory, or the goal that a lot of scientists have had to describe a theory of everything, a unified theory in general. And you know, when you read about that and you think, oh, this is great, wouldn't it be great if we could come to something like that? The Higgs boson reactor thing is maybe an attempt to get us closer. But most people throw up their hands and say, you know, we're never going to find this. If it exists, it's beyond us. And it's kind of pointless. We would have found it by now. Let's just do the real science that solves everyday problems, etc. But I think you have another take on things than that. And you're not as quick to throw out Einstein's initial, well, some of his assumptions, but not his initial assumptions. So why should I, as a person who's reading Scientific American, who's watching science shows on TV, why should I read your book, and what do I expect to get out of it that I'm not going to get, you know, from just watching a documentary on the boson reactor?
Well, what you're going to get is that you cannot dismiss too quickly any claim of so-called fringe areas of science. And you cannot dismiss too quickly stories that sound too radical to be true, like the Philadelphia Experiment. Again, in that book, what I tried to do was to show that you can go and find modern engineering papers, physics papers, and so on, that deal precisely with these topics. And in fact, in the case of the Philadelphia Experiment, you can go to one of Einstein's colleagues, a fellow by the name of Arnold Sommerfeld, all right? Sommerfeld published theories about how it would be possible to cloak things, basically create radar stealth, all right, by changing the incidences of refraction and so on, and cloaking things by making the incidence of refraction near to 1, and thereby basically cloak it, make it invisible, all right? So in other words, the literature is there, once again, at the time period in question. The engineering literature is there. Now, why should an average person care? Well, it's very simple. Anytime that you, and I've said this over and over and over again, almost like a mantra, anytime you are dealing with a physics claim that says that the fabric of space-time, or the zero-point energy, or the quantum vacuum energy flux, whatever you wish to call it, anytime that you are asserting a capability to engineer that, even at a minute level, locally on the laboratory bench, that means you've taken all of the things that Einstein wrote about warping space-time in the presence of a large mass like a star or a planet, and you bring it into the laboratory bench. What that's telling you is that you have the potential for an energy source that, number one, is virtually inexhaustible. All right? That means if that source ever got out, if it was ever engineerable as a practical energy supply, the entire financial energy system of the globe would change instantly overnight. That's the first implication. And therefore, if you were to suddenly release a technology like that, it could collapse the system. So if you're going to release it, you have to do so in such a way that you deliberately manage a transition to that new energy and financial system. All right. And that, incidentally, is what I think is underway right now. All right. In other words, the technology is there. It's beginning to come out. NASA has just come out and basically acknowledged the reality of a propulsion system that apparently is drawing on minute amounts of this 0-point energy in microwaves, all right? So in other words, they're telling you the technology exists, and they're acknowledging it openly. That's huge. 10 years ago, this would not have been done. The other thing that it does, and I've said this over and over again, is if you weaponize a technology like that, if you had a shoebox full of 0-point energy from a shoebox in space, all right, that shoebox would contain more energy. It would contain enough energy to blow up planets. It would contain enough energy to blow up stars. In other words, the weaponization potential of this stuff is gigantic. It's enormous. And again, it takes us back to Giza Death Star. If you're going to blow up planets, you have to have a very, very different physics than what we have now. So in other words, all of this is huge, Daniel. It has enormous implications, and that's why you should pay attention to it. Now, let's put this in the context of string theory. String theory is the reigning macro theory in physics. Its explanatory power as a mathematical formalism is immense. There's a problem, however, in that any version of string theory is not testable. It's beyond, the energy requirements are so gigantic that this is not a theory in a standard scientific sense in that it can be tested, all right? What I'm suggesting is that already there are technologies beginning to leak out. I think they've been around for a while, quite frankly, but they're beginning to be talked about and acknowledged openly and publicly, and that's huge. And that also implies that there's some sort of different physics that's been hidden for a very long time that's also being gradually leaked out. So there is a paradigm shift, in my opinion, coming. That's why I'm talking about all this.